Hi, I'm Benny D, and in this video we're going to look at notation for transformations. So, if we've got a point x, y is any point prior to transformations, then the point x dash y dash, okay, is the image of the point after the mapping, okay, or transformations have occurred. So mapping is just taking points on one plane, okay, and under a series of transformations, putting them onto a new plane. Both of them will be a Cartesian plane for what we're worried about. Okay, so we're going to have a little look at what some of these actually look like. So a reflection in the x-axis, okay, so that means that our x dash is going to just equal our x, so nothing's going to happen to our x values, okay, but y dash is going to equal negative y because we're being reflected down. Okay, if we think about our reflection on the y-axis, this time we're going to have x dash equaling negative x, our transform value. It's going to equal our negative x values, okay, because we're being flipped this way, but our y values are going to stay the same. Okay. If we look at a dilation of a factor of k from the y-axis, that means that x dash is going to equal k times our original x value. Okay, so we're going to multiply it by k. And our y values, okay, aren't going to change. We're going to have y dash is still y. Okay. We've got a dilation of a factor of k from the x-axis. Okay, well, nothing this time happens to our x. Okay, but now we have this dilation happening for our y values. Okay, now you might be saying, hang on, why aren't I 1 on k for this at all? Okay, you'll see why it becomes 1 on k a little bit later on. Okay. If we're looking at moving h units in the positive x direction, then x dash is going to equal x plus h. Okay, nothing's going to happen to y. I'm running out of room, so I won't worry about writing that one. Okay. K units in the positive y direction, well, nothing's going to happen to x. So, but our y dash is going to be y plus k. And the deflection in the line y equals x. Okay. So we've seen our reflections before in our line y equals x. So what that's going to mean is that we end up with our x values, okay, our x dash values equaling y, our y dash values equaling x, because we switch our x and y. Okay. And kind of in summary here a little bit, our notation is that t for transformations maps our real numbers at squared, because we've got our two axes, so our x and y axes, to a new Cartesian plane with x and y axes, so it's r squared again. Okay, and t for transformation of our x and y values equals our new x value and our new y value. Okay, but we've got to see how we actually put this into action. So, got a couple of examples here. So our first one is let t be mapping r squared to r squared, okay, and we get an x value of 3x plus 2 and y dash is 4y take 6. We're going to use these transformations to find the image of f of x equals 2 to the power x. So what we do is we say x dash equals 3x plus 2 and y dash equals 4y take 6. Now what we want to do is we need to sub this x in here, okay, and this y for our f of x. Okay, so if you like, you can think of this f of x being y equals 2 to the power x. So we're going to put this y in here. We can't do that. We need to rearrange. Okay, so we're going to go x dash take 2 divided by 3 is going to equal x, and then here we're going to say y dash plus 6 over 4, okay, is equal to y. Now what we do is we sub these values in, okay, but we're going to ditch the dashes now. So we're going to say then that we get y plus 6 over 4. And if you like, this process that we're doing right now is doing the mapping across. So we've set up for the mapping, we're doing the mapping across. So on our second Cartesian plane, we don't need dashes. Okay. So then we get 2 to the power of x take 2 on 3. So almost there, we can't really fix up this too much, but we rearrange here. So we can say then that we're going to have y equals 4 times 2 to the power of, I put it in brackets, x take 2 on 3. Okay, and we're going to take our 6 away. Okay, so we've gone through that process. Now you also note here, I started off with 3 as my coefficient, okay, of x. Now look, we've got that 1 on 3 happening. Okay, so in C where we get that language with our 1 on n language for our dilation factors that we've been using previously. Okay, now the next little bit is about composition of transformations. So all this is really saying is we can combine transformations. Okay, so and we know that because we can do transformations, and there's no reason why you couldn't transform the new function that you've gotten. So we're basically saying here, if we've got one lot of transformations is equal to 2x plus 3, comma 4y, so there are 2 points, x and y, and t2 is given by 3x and y plus 3. We want to find t2 of t1 of xy. So what we do is we go, okay, well, what's happening here? Okay, well, t2 is wherever I had x, I'm going to times it by 3. Well, what I look at here is this is all my x. Okay, this whole first part needs to get times by 3. So this is going to equal 3 times, oops, I need brackets here, 3 times 2x plus 3. Okay, and our other value, okay, is we're going to add 3 to our y value. Well, our y value is here, which is 4y plus 3. Okay, so it's nothing crazy this little part about our composition and transformations. Okay, we can do them together. Okay, we're allowed to do them together. So you can transform and then transform again. It's basically all we're saying there. Okay, the next little bit we've got, okay, is about inverse transformations. Okay, so a transformation T is 1-to-1 if T of x1, y1 equals T of x2, y2. And this implies that x1 equals x2 and y1 equals y2. Okay, is what we're looking at there. T negative 1 is called the inverse of T, and it's such that our inverse of T of x dash y dash will get us back to xy if T of xy equals x dash y dash. So basically, if we're defining our values here, if I do the inverse transformations of my transform value, I'm going to get back to my original. So it should undo it. So another way to think about it is T of inverse T of x and y is going to give us xy. They're going to cancel each other out. So our transformations and inverse transformations are going to cancel each other out, basically, is what we're talking about here. Okay, so we're going to have a look at an example here. We want to find the inverse transformation. We've got T of r squared to r squared, Txy equals 3x take 2 and 5y plus 3. Okay, so we know that if we go t negative 1, okay, of xy, we're going to get xy. So they're going to cancel each other out. Okay, so we're going to say let inverse t of xy equals, we're going to let that equal x dash y dash, is what we're going to do. Okay, then that means that transformation of x dash y dash will get us back to xy. Okay, that's what's going to happen. So what we can say then, okay, is that 3x dash take 2 negative 5y dash plus 3, okay, that's going to get us back to xy. It's going to get us back to our xy. So that means then that 3 x dash take 2 is going to equal x, okay, and negative 5 y dash plus 3 is going to equal our y. And now I can simply rearrange these. Okay, so we need to rearrange these to get x dash and y dash. Okay, so I'm going to go, got x dash, x dash will equal x plus 2 on 3. So that should be my dash. Y dash is going to equal y take 3 on negative 5. Okay. So sometimes you don't have to use x dash and y dash. In textbook, they actually change it to w and z, I think. Okay. It doesn't really matter too much because you're setting this up. Okay. But we've got to rearrange to see where our transformation would be. So if you want to, you could actually do our combinations of transformations that we just did before, because we should see that we're going to end up having this hold true. Okay, so there's a little bit to this section. There's a little bit just about transformations of subsets as well, and basically they work in the same way. It's a quick little summary there, so you don't need to get stressed if your summary isn't all. Your domain isn't all real numbers. Like if we're not mapping r squared to r squared, if we're starting off with something smaller, that's fine. Okay, all this still holds true. So look, hopefully that'll be enough to get you through some of your questions on this section.